Good day to you, as usual, whenever you listen to these knowledge programs. Thank you very much, Rick. Today, as usual, we carry on with teaching, and we further try to expand our horizon of knowledge and being enlightened, that we can achieve more in so many ways in different aspects of the development of the technology. As usually, we make some comment on what is getting developed and what is going on around the technology. At this moment of time, due to the way the technology is working and is expanding, is that we have come with the authorities to the point that we have to bring standards into the structure of the plasma. What this means is the scientists at governmental level and scientists at institutional level have start understanding the process. They have started comprehending the changes that this technology is bringing. They have started putting the materials and the conditions these materials produce into test and seeing the results very rapidly. Now, as usual, as is their job, they're asking what's next. We have to develop a standard for this. So we are working now with governmental institutes, and in a coming time we'll ask for a lot of help from you knowledge seekers who are expert in these kind of things, or you have seen a way of doing it in an easier way, to collaborate with Keshe Foundation Ghana. And then it goes with a standardization of finding new systems, new ways to measure what we have developed. What this means is that we have developed the GANs, we have developed nanomaterials, we have developed the interaction of plasma, liquid plasma, what we call the water, which has no traces of the GANs in it, but carries all the property of the material which is used. So now we have come to redefine a lot of understanding about the technology. What we had to do in the past few weeks, working with scientists at the governmental level to bring the situation under the understanding of the totality, when we call a measurement what it is, we had to explain a lot of things in a new way, which gradually will filter down and people will understand. We call the GANs production of the liquid plasma. How do we create it? What does it do? How is it achieved? For example, if you put a cup of GANs and then put water on it, mix it with the water. We all have seen it. The water moves up and the GANs settles. What does it do? How does this happen? Why do we get like the material of the GANs at the bottom? And what happens to the water? In fact, if you look at it, it's a filtering system. We are used to the filtering by water going through the filter and come out the other way clean. But with the GANs, because of its property, it's totally opposite. You can put the GANs on the top, and as the water goes through, it filters the water. So the GANs process for production of the liquid plasma, we call it the filtering now because it's easier way. When the water goes through, this layer is not solid, it's not like you put a chalk and calcium or whatever in the solid filters now. You get now a mixture of the GANs filter. This has changed a lot of understanding for the scientist. It's a filtering process. And in that filtering process, it goes through bacteria change as much as anything else which could be in the water. Now we are learning more and more about this filtering. And now we can quantify it. We have to start quantifying it. We've seen the American company who took the GaNs of gold as a nanostructure, and we saw it in presentation months ago, how they have mixed the solid GaNs of gold in other sediments as a layer of filtering. So we created a new system. We have created a liquid filtering, or what we call in a state of non-solid state. This has given us a new way, easier to be able to explain the process to the scientist. Now this has pushed us to the next level. What we saw in TEPCO in situation with the testing and then implementation of it was the scientists in TEPCO came up, we cannot measure, this thing keeps on going, the more water we get from it, the lower it goes. So we have done with TEPCO 2 years ago to dry the GaNs. So now we can use a dry GaNs as a filter. You can literally put it there as filter. But now we can measure it. So many milligram of GaNs has such a strength, has such a properties. The other thing now we are facing with the scientists is, for the first time, we have to explain the strength of our GaNs in a totally different way. In a totally different way than we are used to. I was just explaining before we start. We have to start explaining GaNs in a three-dimensional property matter, which never been done before. It becomes a three-dimensional entity at such a point, with such a gravitational strength and with such a magnetical strength, in such a position in the space of the plasma. This behavior is, let's say, characteristics of hydrogen. At the same time, we change another parameter, is the property of what we call determining what other element is in the vicinity of the hydrogen, that it gives this representation. Very much what now we look is the expansion into knowledge of the space technology. In the present time, we call it GPS positioning. But if you look at the aircraft industry, the air tunnels, they give you position, altitude, the height, in 3 dimensions, where we know exactly where the aircraft, in what position on Earth, at what height. This has become necessary to be adopted for the plasma technology. But if we look into understanding of this, this allows us to map up the universe, to map up the strength in galaxies, to map up positions within the solar system. The way we say, I'll meet you at such a service station on a motorway from that city to that city, now we should be able to map up position in the solar system that we can meet. Considering that we understand the magnetic field, gravitational field positioning, the motion of the fields, the motion of the plasma of the solar system, and the rest of it. This is where now we've been asked to work within the governmental structure, within the scientific organization, to bring a standard, to bring understanding that we can quantify. How much GaNs do we need for such a job? can we replace it with such a strength from copper instead of zinc that we get approximately the same? We are talking now to understand the level of the absorption, how much of it gets absorbed and what it does when it moves on. What it changes the position of the strength after giving. It goes, for example, from what our body does. It takes cobalt, it gets other materials, it gets cesium, it goes through the body. When it gives its radiation and it becomes non-usable, the body has made itself a measurement tool that the radioactive material in the body of this element is not strong enough to be absorbed by the body or has any effect in its operation. So the body rejects it to go out, that there is a place for a new one. So the knowledge we need to learn is what our body does already. We have a point of reference. How does body measure that radioactive material in our limbs, in our what we call substations of the brain, the glands, decide that is not effective anymore, that it needs replacement? So the body has built a measurement system for itself. We never knew these. Now we know. Now we have to understand how we can develop technologies that we see the effectiveness level of any material that gives us an after as is a radiating material and absorbing. After this level, it cannot behave like, let's say, copper. So automatically we have to find a way to replace it. It's more or less what we call sale by date. We call it sale or change by the strength. These are the new challenges which, now that we have come to legal registration of the different materials, is baffling the scientist. In a very short time, we will call for world scientists to gather in Accra to start standardizing. Because all of you are producing these gases, you are applying it for different applications, but we have no measure. Do you need 1 spoon of sugar or 2? How much sweeter you want it? The process is very rapid. Now that the legal frame and organizations around the world are getting to understand with our work with the organizations, scientific organizations, standardizing organizations in Ghana has started. We see other governments coming in because they're getting used in their country. In the next 6-12 months, you will see a massive move in standardizing. We have had a meeting in the past few weeks with number of scientists, 10, 15, a group from different registration part, that understanding is that we have to do something with it now. So what we need is from all of you who've been around, or you work, or you see, to come up with different measurements and how you see one thing can be measured to copper or can be confirmed to be CO2. This has become essential because this way, for example, I can sell a water from a tap and say it's a CO2, and I can sell a water from the tap, putting through the filtering system, what we call a plasma liquid, and tell you this is the CO2. We are looking now in organizations to bring a system. It'll take months, take years, it won't be tomorrow. Where, for example, in the house you buy water, which is, let's say, it's a gas of CO2 or zinc, or your label is washed off, you don't know what it is. You can put your bottle in the machine and it tells you this is what it is. These are the realities we are facing now that we're becoming nationally and internationally organized to develop technologies. As I said, in the coming years, there will be more people employed because of this technology that man could ever imagine. We are facing it. Now, it's an everyday situation for us that it's not the technology is rejected, we have to resist it or whatever. Now it's on the table, people are using it, we see the change, let's measure it. Let's bring some sort of standardization worldwide. In the coming weeks, FDA worldwide will gather in Ghana. It's something we have to do it, and it's getting slowly planned. Standardization by the standards boards around the world is organized, getting organized. They are calling people, scientists in. Let's measure, let's do something with it now. The point is, we have a product on the table. We have a number of products on the table. We see the results. We see the outcome. We see the positiveness of the use. How we're going to measure it. So, the step for us now has become, as a new technology, we need new measurements, new tools. A 3-dimensional, maybe a 6-dimensional. The way we do in nuclear reactors, we work on 8 dimensions. When I used to work as a nuclear physicist in design of the nuclear reactors, we used to work in 8 dimensions sometimes. The heat comes into it, the pressure comes into it, the transfer of field from the others comes into it. These are all variables. Now, after 30 years, I'm facing with the same situation with the plasma technology. Because I understand it, I can see how this can be done. We got the situation now with a flight test in Arizona. In Arizona, now they can increase and decrease directionally the field span. How do we measure it? How do we expand it that one side takes pressure and the other side creates a shielding? If John is on the line and he's awake, maybe he can show us. It's the latest test they've done. For the first time, we see the property of electron and a proton done in a very open way. Do you see John in the background?
Don't see him right now. Anybody else have any information on that?
No, it's just a private video. Well, I'll bring it up. We can share it. It's on the emails. Let me see if I have it. We can show it. Just 1 second. What this is, I'll try to find it while I'm talking with you, that you will see it for the first time. We come to what we said. In the direction of the motion, we need to decide which way we are going. In the production of the energies, we see how materials move, how we can produce material out of fresh air. These are the things now in laboratories we are facing. What I'm going to do, Rick, I'm going to send it to you on your, what do you call it, on the Zoom account. You can download it and you can show it. You will see an interesting effect. And this is important. Now, how much field do we, how do we measure in what fields are applied in which way? These are the problems, or these are the joys of new space technology. We are forced to now, by governmental institutes, to quantify the measurements. This is what they expect, that we can understand what's the next step. How far the next steps affect us in which way. For the first time in the test, you see is that the material has become itself part of the innovation of its own technology in understanding itself. We have to understand. We have no choice. Rick is on your Zoom account. Can you see it?
Yes, just getting it lined up here.
Yeah, just open it to see it's the one. You'll see it, that they move to the one side, the field has expanded to like 16, 18, where on the other side it stays as 12. If you go back into the teaching of 2 or 3 years ago, this is what we explained. You expand, you extend your field in the direction of flow. Then you can increase it by a strength that you create a stronger shield in the direction of flow. This is what we have to learn. This is how we have to standardize. This is what is becoming part of interaction of the work.